This is Chapter 6, Problem 23. In this problem, we kind of have what looks like a problem from hell. Basically, a semi-Atwood machine with two hanging masses and a mass on a table. We assume that the whole system is going to go up and to the right, since we have a 2m mass on the right-hand side, and that's bigger than the m mass that's on the left-hand side. We also have the 2m mass on the table that is going to supply some friction force. Now I'm going to do this using the voodoo way, but you can use it with tensions. Just make sure that all the tensions should cancel out in the problem, and you have two tensions. That's why I think the voodoo way is so much easier. We have that the net force on the system is equal to the total mass of the system, 2m plus m, so a total of 5m, multiplied by the acceleration of the system, and we know that the acceleration of the system is equal to 0.5 meters per second squared. That's going to be equal to the mass that is hanging, the 2m mass times gravity. That's our driving force in the problem, and since that's going down on the right-hand side, we assume that that's positive, so 2m times g. Friction is going to oppose our motion on the table. That'll be mu times the normal force, 2mg. And remember that in the problem we're trying to find the coefficient of kinetic friction, which is mu. Then the other force that's trying to keep this system from moving is the hanging mass on the left-hand side, so minus mg from the left-hand side hanging mass. With a little bit of cleanup, we now have that the total mass on the left-hand side, 5m, multiplied by the acceleration of the system, 0.5 meters per second squared, is equal to the 2mg driving force from the right-hand side minus the mg on the left-hand side trying to resist the motion minus the force of friction from the box on the table, 2mg times the coefficient of kinetic friction. We can simplify this, the masses drop out, so now we are going to get that 5 times 0.5 is equal to 2mg minus mg would become 2g minus g, or just g, 9.8 meters per second squared. Remember, do not put a minus sign on that. We took care of all of our minus signs already in the start of the problem. And then minus our mu multiplied by 2 times g, since our mass dropped out. And if you solve this thing for mu, you're going to get that mu is equal to about 0.37 or 0.38. Remember, we did this using the voodoo way. We set up the complete picture of the problem. The 2mg on the right-hand side is trying to drive the force of the problem. Friction opposes our motion, and then the other hanging mass on the left-hand side also tries to oppose our motion. We also need to use, in our F-net equation, the total mass of the system. That's 2m from the hanging mass, plus 2m from the mass on the table, plus the other hanging mass, m, for a total mass of 5m.